right. I'm coming up here as I feel like I'm Miss Swag here. I've got my new little cell phone holder and water and shades, so I'm like stoked on all the free stuff. So I don't know if a lot of you guys here are for the free stuff, but I'm here to. So next week I'm going home. I live here, so I'm kind of on vacation all the time. But next week I'm going home to Minnesota, and yeah, Skoll, right? Anybody who's here from Minnesota? Next week, going home, my cousin is in stand-up, and I want to do that with him. So this is my first kind of public speaking, little practice. But meanwhile, I'm a programmer, so I feel like I have some funny things to say about programming, all right? So I'd like to say thank Chloe, and because as a programmer who's locked in a padded cell all day, it's nice to laugh. And I think we don't laugh enough as programmers, so here I am trying to make us laugh, and you know, my boss shoves me away in that padded cell, says go do XYZ, little inside joke because I just did a plot on XYZ, and I work at Scripps Institute of Oceanography. My goal, you know, save the oceans. So that's what I do on my day job, and meanwhile I crack myself up all the time. So I thought, hey, might as well give it a try, you know, cracking some of y'all up. So we're in the land of the hippies, aka San Diego, and we like labels. So I actually don't have a button because I don't really care for labels, but I respect other people's labels. And so, you know, except for food, I'm always like, is this local, organic, shade-grown, fair trade? You know, I like my food labels, right? Well, another thing of Land of the One, we like to be one with each other, one with nature, one with ourselves. Let me tell you about what I wish we were one with: time. It's just like there's just never enough time, right? And anybody program with time zones? Time zones? Oh, those are fun, aren't they? Because, oh man, there's more than just 24. When I'm talking to normal people, I'm like, oh, I know a lot about time zones, man. There's more than 24. Some of them are 30 minutes or 45 minutes apart. And then there's daylight savings time. I am like, please, can we get rid of this? Like, I've been looking up on the history of this because I'm like, this just is archaic. This needs to go. Programming, you're just like, oh my God, can we not just all be one with time? It's called UTC. You know, I wish that'd just make my programming life so much easier. So, new to social media. I just started my Twitter. Thank you. I started my Twitter today because I was like, it's in a spreadsheet, and I love to fill up spreadsheets. I've been doing spreadsheets since I was 10, so Twitter. All right, been meaning to do this. I procrastinate sometimes, just need a little push. All right, made a Twitter. Twitter is Pico de Loco. There's one. But because there was already a Pico de Loco, I just made an Instagram account like a month ago. Only a few posts, a lot of cats, dogs, you know, and I skateboard, and so anyways. So it's me, right? Well, I was Pico de Loco. I do Twitter. There's already one. So I'm Pico de Loco 1. Well, okay. Well, all right. So I'll get on Instagram, change my name now, and I am now Pico de Loco 1. Because guess what? I am crazy. I was crazy once. They locked me in a room with bugs. Bugs make me crazy. I was crazy once. They locked me in a room with bugs. Oh, yes, because programming bugs make me crazy. Especially when you're all alone trying to figure out a bug. It makes me crazy. So I'm crazy. I embrace the crazy. I am proud of my crazy label. Some people think, oh, crazy's derogatory. No, I'm crazy and I'm proud. So, oh, I got 1 minute left. Sick. I'm going fast because I talk fast. So try to listen fast because I ain't slowing down. Can't stop, won't stop. Social media. I'm on social media still, so I'm new to things. I got this 360. I want to get a YouTube. Haven't done a YouTube video yet. Going to. I see you. And focus. That's what I need to do. I have a little bit of ADD. I'm having a hard time right now staying to this microphone because I like to move. And my boss, meanwhile, I just sit in an office all day trying to sit on that chair. I'm trying to be really good. I'm trying to be a good employee, trying to sit on that chair, sit all day. Sometimes you get tunnel vision, you get in code mode. You're just going, right? Meanwhile, oh, dang it, I got to go to the bathroom. Boom. That's when you figure something out, is when you stepped away, right? You step away, you realize, I need to step away a little bit more often, you know? Because we all need to step away. Anyways, last thought, trying to save the oceans. Sometimes there's labels. Respect those labels, including recycle labels. Some of y'all using recycled cups or whatever. Hey, try to put it in a cup. Try to put it in a bottle. If you're not, if it's a recycle, make sure it goes in the recycle. Thank you. Want a hug?
Well done, well done.
Thanks. Hi, everybody. I'm Tim. I write code for the Wharton School, various open source projects, and most importantly, for myself. I help organize DjangoCon US here and also the Philadelphia Python users group back home. I started writing code when I was 6 years old because my mom won a raffle, and have been doing it ever since and absolutely love it. I consider myself very lucky to get paid to do what I love with colleagues and friends that are close enough to be considered like a second non-DNA family. So let me show you my GitHub chart from 2014. Did that look like the chart of somebody who likes to write code a lot? The truth is, in 2014, I wasn't doing what I loved. I had been slipping further and further away from doing what I loved for a long time. And, you know, while I still worked hard and had a lovely home, squaring who I thought I was and who I should be with how I acted was getting harder and harder every day. And looking in the mirror was getting harder and harder every day. So it was because of this that I had to change just one thing. So what happened here? For many, many years, I had been trying to change just one thing on my own and failing. Finally, in April, I asked for help with my alcohol addiction problem. In May, I got out of rehab. And you can see a sudden uptick in activity there. And I've been clean and sober one day at a time ever since. So, thank you. So what happened here in July and August? I made a terrible, terrible, tragic mistake and reopened my World of Warcraft account. So 2016 looks like it might be a bit of a lighter year, but I was contributing to several private repositories, and me and my friends from Wharton were also a little busy helping host this conference that you may have heard of the year it was in Philadelphia. But when we take a look at 2017, this is where I really started to hit my stride, having gotten more involved with a bunch of open source projects. And from Wharton, we also started to put some of the packages we had been developing internally on GitHub and PyPI. And if you take a look at 2018, it's up to, so the first year was 21 contributions in the year, 1,053 in the last year. So as you can see now, I'm pretty active again and doing what I love, writing code with a community of friends, old and new. It's been such a wonderful way to connect and just such a better life. So what I just really want to do here is ask everybody, if there is one thing that you could change about yourself, one thing that you don't like, what would it be? And how much better could your life look if you could change just that one thing? It doesn't have to be an addiction like I had. It doesn't have to be, you know, only you will really know what it is when you look at the mirror at night. But I want to encourage everybody here to, you know, if you do have that one thing that you want to change about yourself, it is worth doing. It is worth asking for help for. I couldn't do it until I asked for help. And I've had support not just from the rehab center I went to, and not just the recovery communities I've been in. My colleagues at work have been incredibly supportive. The Django community, which I've immersed myself in ever since, has been incredibly supportive. And it's been an amazing amount of support everywhere I've looked to try to keep this going one day at a time. And the same thing could happen for you. Because if you need help to make that change, you know, absolutely ask for it, because it really did save my life. And you know, as Gandhi said, we must be the change we want to see in the world. So if you have a problem, sometimes changing one thing can change everything, and it really did for me. Thank you very much.
Hello, everyone. I'm a software developer and I write software, but occasionally I do not only need to write software, I also need to write documentation or put up a website for the software that I've written. Both things usually include screenshots, and doing screenshots is cumbersome. You want to do them on different screen resolutions, you might want to do them with different locales, and once you're all done having created them, they are outdated and you have to start over again. So let's automate this. And let's automate it with tools that we already know, or that probably most of you have already seen. The first tool that we want to use is Selenium. You might know Selenium as something to write front-end tests for your web application. Basically, it's a way to remotely control your browser from a program. The next ingredient is Chrome Headless. Chrome Headless is a way to start Chrome without requiring a display or anything attached, so you can run it on a server without needing to have a full-blown desktop operating system. And then we use PyTest. PyTest is a test runner, but if you look at it closely, it's not only a test runner that makes it easy to define tests and run them in specific ways, but basically it's a way to run functions in a specific way. So usually you have a test that is just a Python function prefixed with test underscore, and that checks for something, and then you run PyTest and it finds all of those functions in your project and runs them and informs you about the result. But PyTest can do so much more. It can have parameters for input and fixtures and so on. Fixtures, for example, are things that you want to that should be there before the test is run. So, for example, in this code snippet, we are testing in the SMTP library, and we have a fixture that creates an SMTP connection object, and then we have a test that declares that it needs this fixture parsed as an input. And for Django, there's PyTest Django, and in Django itself, there's live server test case, which allows for creating a test case that accesses an actual run server-like version of your app. So with all these ingredients, we already know them. They're usually used for testing. In this case, we will use them for screenshotting. And to make it a bit nicer, we use PyTest's configuration to redefine some strings. For example, we want to define our screenshots in scene files with shot functions and not in we don't want to call it tests. And then we can use fixtures to create objects, because nobody's interested in screenshots of an empty application. We want to populate the database in some way beforehand. And we can define, and as another fixture, we define the Selenium client that is already logged into our system. We can also define our screen resolution in a fixture, as well as any other options that we want to pass to Chrome. And then we can define every one of our screenshots by simply writing something like a PyTest test with specifying what fixtures we want to be run before, and then just calling a utility function that does a screenshot with Selenium. And we can run it by just calling PyTest on our folder, and we're done. And with PyTest parameters, for example, you could do this for every language that your project supports, or for every theme that your project supports, or whatever, and you end up with a bunch of screenshots. For the application I'm working on, you can find the repository with the screenshot definitions and also the utility code that is a bit more complicated than I've shown here in this GitHub repository. And thank you very much. If you have any questions on that, feel free to talk to me in the hallway.
Thank you.
Hello. It's time for our story. Today's story is That's Not My Emoji. That's not my emoji. Its head is too shiny. This is two emoji put together. This is not an emoji. This is not my emoji. Its face is far too animated. Can you make a unicorn sound? Emojis do not have sound. This is not my emoji. Its existence as a character in a movie is far too distressing. You see, when a studio loves a marketing opportunity too much, they can make a terrible movie out of it where a bunch of the main characters aren't actually emoji. That's not my emoji. It is partying far too hard. You see the pretty bird? He's dancing. Emoji do not dance. That's not my emoji. Its permutations are underdocumented. Can you wave at the Kai emoji? Hello. That's not my emoji. Its ligature is only vendor implemented. You see the cat drinking coffee? Cats don't drink coffee. And this only appears on Windows 10 operating systems. That is my emoji. Its code point is so standardized. And that's the end of our story.
Okay, sorry about that. So yeah, this is a talk about crypto, but it's not a talk about that stupid new thing. This is a talk about the original crypto, which of course is cryptozoology, the study of cryptids or legendary stroke mysterious creatures. You know, we're talking Bigfoots and chupacabras and the Michigan dog-faced man and all of these wonderful things. And the reason I'm interested in cryptids at the moment is that last week I was in Ohio and I went bat detecting with my wife Natalie in the woods in the dark. And it was dark, and it was the woods in Ohio, and we realized that we hadn't really done our research, and this is America. There are weird creatures out here. We didn't know if we were within the range of any of these mythical creatures, and I'd like to know so that I can greet them and say hi. So I obviously hit Twitter, and on Twitter I said, so just out of interest, does anyone know where I can retain range maps of cryptozoological creatures like yetis and chupacabras and so forth? And then I asked a question about it on Ask Matterfilter, and I realized that actually no, the internet does not have a conclusive source of range maps for different cryptozoological creatures. So I started a GitHub repository, and this is a GitHub repository which I would actively encourage people to contribute to, where I am trying to get a directory of information on cryptids and their ranges. And so the way I'm doing this is using a file format called GeoJSON. It's a brilliant format. It's a way of representing geographical shapes in JSON. So let's take a look at the Loveland Frogman. This is my GeoJSON file for the Loveland Frogman. A great thing about GitHub is that GitHub knows how to render GeoJSON. So it's rendering this shape for me, but if I click on that shape, I can see that it's got a Wikipedia URL, the name, it was first cited in 1955, last seen in 1972, and it's a humanoid frog described as standing roughly 4 feet tall. So that was my first cryptid. I have been, you know what, I've got some pull requests. Russell has sent me a pull request adding the drop bear. I'm going to merge this right now, and if I'm lucky, it will deploy by the end of my lightning talk. I should have done this a couple of minutes ago. So we now have a drop bear, which is very exciting. So you get the idea. So then what am I doing with this data? Well, so I've been working on this open source project called Dataset, which is an application that takes a SQLite database and gives you a UI for exploring it, and it gives you an API for getting the data back out as well. And it's the perfect application for cryptozoology. So what I've done here is this GitHub repository has Travis set up to run a script every time I commit anything, and the script reads in the GeoJSON and writes it into a SQLite database. It's all of, 123 lines of code. There's not a lot to this. So it builds a SQLite database with all of these cryptids, it deploys it, and then based on this, I can build out an API. So here is the nice thing about Dataset, everything's SQLite, so the API is just a SQL query. Here is a SQL query that selects details of cryptids where the geometry overlaps where within geomtext, so where the geometry overlaps a point. Here's our current latitude and longitude right now, and if I run that query, I get back the Bigfoot. It turns out America has a lot of Bigfoot sightings. So this is now a JSON API which you can feed latitudes and longitudes to, and it will tell you which cryptozoological creatures you are within range of. Here's Travis. Oh, look, Travis is building the drop bear right now. So if we're lucky, that'll be built and deployed in just a moment. I'll talk about Bigfoot quickly. It turns out there is already a database of Bigfoot sightings run by the Bigfoot Research Organization, who are banned from Twitter. If you try and tweet a link to bfro.net, you get an error message. So clearly Twitter are part of a cover-up conspiracy trying to hide the existence of Bigfoot. But they've got 3,000 sightings. They publish a KML file. A KML file has latitudes and longitudes in. I happen to know that the range of Bigfoot is 15 miles from a conversation I had at the Bigfoot Discovery Museum outside of Santa Cruz. Thoroughly recommended. If you take those 3,000 points and put a 15-mile radius on them, you can see that Bigfoots have been sighted across much of the United States, everywhere in Florida. It turns out everyone in Florida has seen a Bigfoot, and here in San Diego. So when I ran that query with our San Diego coordinates, I did get back the Bigfoot. I've got a iOS shortcut that isn't working at the moment, so I can say, hey Siri, check for cryptids. That's very useful. And if you want something a bit more useful, I do have a version of this that works for time zones instead. So please take a look at the project. Draw maps of cryptozoological creatures. Since they probably don't exist, you don't have to be very accurate. And let me know how it goes on. And before I get hugged, I'm just going to quickly see if Russ's drop bear has deployed yet.
Myself.
Unfortunately, it looks like the drop bear did not quite make it, but in a couple of minutes there will be a drop bear, so thank you very much.
All right.
Begin.
Thank you. Okay, this is the first presentation I've given in a very long time. This was from something I did literally 8 years ago, so I'm going to try and do this really quickly. In 2010, I was at a place called the Santa Fe Institute for a summer program, and they asked us to create various research projects. So me and some friends stuck something together in 3 weeks, which was a Django app, which you'll see. 4 years, that should have said, 4 years later, I got diagnosed with a really complicated situation, which is why I've had 3 surgeries and why I can't have this part of my glasses on that side of my face. Long story. Still managed to get a PhD in sociology. Now I'm trying to figure out what to do. It went so well, my most recent surgery in June, that I'm here, and I'm really, really happy to be here. And my GitHub name is Spool. If any theater nerds who know Crap's Last Tape get that reference, please see me after, because very few people do. Right, okay, so the project was to try to study how people collaborate creatively and how they might respond to each other in making a design. I'm going to skip over that because that was a lot of, again, some things I had before. You can ask me stuff about. But basically, if we're working together on making a design, how do people respond to each other's things? People may be aware of the whole Reddit project that came a couple years ago. This came before that, technically, in 2010, and you'll see some differences in the user interface. So the idea was we printed a T-shirt at the end. It was going to be a black T-shirt by default, and then we were going to put some designs on it. We wrote it in Django and a language called processing, which is really cool for doing some user interface and sound experiment stuff. There was a processing JS back then, which was really slow. There's now P5JS, which I really recommend people try if they like to. What we did is we created a grid with 64 cells or squares that people could do their own designs on, and that whole thing became the canvas. And you could only see your Moore neighbors. Can I see a pair of hands, or hands for anyone who knows what a Moore's neighbor is? Okay. Oh, there's one dude. Do you want to tell everyone what that is? Fine. Okay. That's cool. You'll see it in a second. So this is just an example of how we've run it in a museum recently. So you get assigned a square in this big grid, and you can only see the edges of your neighbors. So if you, there's the ones to the left, right, top, and bottom, and then there's the ones on the corners. So those 8 are the Moore's neighborhood. So you can press spacebar, do a design, and then press spacebar at the end, and you see how your design fits alongside the designs of everyone else. Okay. So press play again. So that was that. That was the, you could log back in. So when we ran it at a museum, you could only do one design and then see the whole canvas. The way we ran it as a website is you could log in, you could only see your neighbors. Then if you logged in the next day, you might see how your neighbors changed, and then you could respond. So we had a couple of problems. If someone logged in and then left it for an hour and then logged back in, their neighbors might have changed, and then they would log in, and we ended up, they would accidentally not respond to the most recent changes of their neighbors. We should have done that with WebSockets. We also didn't take into account time zones, so someone's laptop was on a different time zone, and they kept overwriting everyone else's, and we didn't know why. That was really frustrating. This is what it looked like. So each of those cubes are individual people's designs. Oh, the music. That was when a dude tried to do his own and then accidentally overrode everyone else's. And it's a torus, so the people on each side can actually see each other, and the people on the tops can see the bottoms. Anyway, thank you very much.
Well done. Well done. Good job.
So that was the final thing. If anyone's interested in the music you just heard, that's by a really incredible composer named Julius Eastman, who sadly died in poverty in 1990. Look him up. Thank you.
Hello, I'm Ernest. I really like to tweet. You might think that tweeting is my full-time job based on this incredible brand engagement. But in reality, I work for the Python Software Foundation. I also tweet a lot, and so if you want to follow me, that's where you do it on Twitter. But yeah, the Python Software Foundation. So the Python Software Foundation, if you're not aware, is a nonprofit that controls the intellectual property, copyright, trademark, etc. for Python the language. Also, it is a grant-giving nonprofit, and so we raise money, and we pour that money back into the community in order to support events like this, meetups, and smaller events as well. There's a larger event associated with the Python Software Foundation called PyCon. If you're not familiar with PyCon, it was in Cleveland in 2019. It's going to be in Cleveland in 2018. It's going to be in Cleveland in 2019, and I want to talk briefly about that. Currently, the call for proposals for PyCon is open. You can check that URL out to go submit a talk, tutorial, education summit, presentation, poster, or a charless, or a talk in Spanish. Speaking of talks in Spanish, the PyCon charless came out of the PyCon Hatchery program, and so this is kind of what I really want to pitch to you. The PyCon Hatchery program is a way for your ideas to be realized in PyCon. So if you've ever been to PyCon and not seen something that you wanted to see, this would be the way that you would tell us what you want to see, and perhaps even propose to do the work to make it so. So please check out the Hatchery program and read more about that. So you might be saying, okay, like, this is DjangoCon. So what about Django? The Python Software Foundation loves Django. So I'm the director of infrastructure, and so that's like a bunch of services that run on python.org. Out of that, 7 of them are currently written in Django. The PyCon website is written in Django, and I love Django. Admission, I haven't always loved Django, but it's gotten much easier in the past few years. And so being here and being among people who are interested in or experts in Django has been really exciting. And so I'm also going to come up here and ask for your help. I frequently tweet, and sometimes I tweet about asking for help in Python or in Django. More often than not, when I'm tweeting about Django, it's asking for help. So help, please. And when I say this, I mean this sincerely. If you're in this room, it is probably because Django has either made you feel like you have superpowers, or you want to feel what it feels like to have superpowers. And I want you to be involved in Django and the PSF and PyCon, if any of that's true. You might just be starting out, and I'd love to work with you to get you started. You might be an expert, and I would love to work with you to get a little bit more of that expertise, and so that we can all share and grow. So there's also a bonus. It's not Django, but PyPI is a piece of software many of you in the room might be familiar with. And if you're at all interested in contributing to PyPI, we have stickers now. You can check out a micro sprint that's going to be occurring at lunch with myself and Dustin Ingram. And that's it. I'm Ernest, and you can follow me on Twitter there.
Okay, so I'm going to talk about you folks about 1 + 1 = 1, or record duplication with Python. This is a 45-minute talk. I will make it in 5 minutes. Not sure if it will work. So real-world data is a mess. Probably dealt with data like this before. Those are restaurant records, and you see here that clearly those 4 records here from 0 to 3 are duplicates, because the name is quite similar, the address is similar, city can vary. So we have duplicates here. Real-world data is a mess. We don't have unique identifiers. And the solution is to perform the duplication, also known as record linkage, to join records in a fuzzy way using data like names and addresses. Mostly we'll deal with those kinds of dates, but it can be other kinds of dates. And to solve that, we should do some fuzzy comparison of strings. We can use algorithms like Jero-Winkler similarity. If I compute the Jero-Winkler similarity between those 2 similar strings, I get this high number. And with those different strings, I get this lower number. So I can use that as a tip for me, as an indication of similarity between records. I can do also fuzzy comparison of addresses. And the trick is to geocode them to latitude and longitude, and that will allow us to clean irrelevant address variations, like a small variation on the street number or something like that, and to enable the calculation of geometric distance using latitude and longitude, because we want to group and match things that are close together. And if I geocode those 2 addresses here, you can see that although they have variations and even typos, the latitude and longitude is the same, and the zip code is also the same. I can grab this from Google Geocoders, for example. Okay, now into the process of deduplicating a data set. First, we need to preprocess it. We will use the restaurant data set. It contains 881 restaurant records from the folders and Zagat's guides. And it contains 150 duplicates, and we want to find those duplicates. The data set looks like this. So it comes with the cluster column, which is the truth about this data. Of course, we will remove that. And we will also remove the phone column, because it will make things very easy for us. And we will left only with name, address, and city. And we want to deduplicate using only that. First, we clean, just using some regexes to clean the name. We will geocode all the addresses, so we get the postal latitude and longitude for the addresses. And then we can move to the next step on the record linkage process, which is indexing. We will use the library record linkage, also known as Python record linkage toolkit. And we have the cleaned records. Now we want the pairs to compare to find matches. To produce the pairs, we could do a full index. We could compare all records against all records. Of course, that's slow, but we don't have enough time to think about a smarter way to index, so we just produce all records against all records. And the pairs look like this. We compare 0 with 1, 0 with 2, and there it goes. Now running the comparisons. We want to compare the pairs to get a comparison vector for each pair. So the comparison vector looks like this. The names are similarities 0.5, the other similarity is 0.8, and that's our comparison vector. And to compute the comparison vectors, we define similarity functions for each column. We can do that with the record linkage toolkit. We use Jero-Winkler for name, address, postal, and an exponential decay geometric similarity between latitude and longitude. And that's what we get if we run that. Now with the vectors, we want to explore different ways to classify them as matches and non-matches. And we can do some simple threshold-based classification. We can compute a weighted average over those vectors. And by looking at data, we see that those 3 are matches. So we just consider anything with more than 0.9 of a score as a match. And if we do that and compute from the truth about this data, we see that we got 128 true positives and 2 false positives, only 2 false positives, and 22 false negatives. So it's quite good performance, but there are smarter ways to solve that problem. Make sure to check active learning classification. It will help you a lot because it will allow you to build a training set for your data. Thank you very much.
Thank you.
Okay, so as I said, I'm Filipe, I'm partners at Vinta, and let's talk about parks. So I have an image here of two layouts for a park trail or something like that, and I want you to think about which one of those you think is a more pleasant trail for a park. So to be honest, this is a very tricky question. I didn't give you enough information to answer that. And the reason is you don't know anything about the terrain, you don't know anything about if there are trees around, you have absolutely no idea of what's going on in that area. So to answer that kind of questions, you need something like this book, which is called A Pattern Language from Christopher Alexander, and it's from 1977. And this guy, he defined a series of patterns and things to help architects to build and design good and do good architecture. So for example, you can take the pattern 120, which is about paths and goals, and it says the layout of paths will seem right and comfortable only when it's compatible with the process of walking. And the process of walking is far more subtle than one might imagine. This is very interesting, especially because it can be visualized through this thing called desire paths. Desire paths are, like in this image, they show how people interact with the place they live through like these patterns in the terrain. So for instance, here we are seeing there are two paths going, one that goes straight to the door, but there's a fence, and another one that goes around. So probably at some point, the fence didn't exist there. And people just changed the way they went inside the house after that. Also, this other example, so in this case, people are going around the trees. And here is very interesting because like they got the desired pattern, the desired path, and actually made it a fixed path and a proper path. So one thing to remember, and this comes from this idea of patterns and paths, is that when you see a big street, mainly when it's an old one, main avenue in a city, probably at some point there was a better road in the woods. And maybe before that, there was just a path where people and animals pass by. And so those are patterns, and this is from Christopher, the author of the book, and he says, this idea comes simply from the observation that most of the wonderful places of the world were not made by architects, but by people. So the book is really very based on this, on how architecture is built by, is made by people and constructed naturally. So the book has other patterns, and for example, the path-shaped one, there is seat spots. So when you, sorry, it's missing. Okay, so there's another part that's missing here, which is about language. So it's a pattern language. We talk about pattern and language. It's just like when you have words. You have words that have separate meaning by each of them, and when you group that together, you get a lot more meaning through language. So language is that's a group, you group words to convey a lot more meaning. And that's where we get to design patterns. So design patterns was actually created, the book we know, the software book we know, it was actually created based on Christopher's book. And I don't have a lot of time to talk about like design patterns here, but like it's just that that idea that it comes from. So let's just jump through some takeaways. So first thing, design patterns are not created, they emerge. So just like the Christopher's patterns, our design patterns are just observation from how people code. Design patterns are a tool for communication between programmers through speech and code. They are not to brag about, they are to help you communicate with your teammates. And the last thing I want to leave to you is that quote that says, Good architecture is about improving people's lives, and most of the time, this means that what feels more natural or more pleasant to us. And this applies to both to architecture and to programming. Thank you.
Thank you.